We're all familiar with the sound of a winding watch. That clicking sound comes from the click hitting each tooth of the winding wheel, and this is what the mechanism looks like in most watches. So how do all these parts get made, and what makes the mechanism in my watch a bit different? Well, it all starts with the square hole, and as I previously discovered on Patreon, making this is actually harder than it looks. Here, the purpose of the square holes is to connect the winding wheels to the barrel arbors. At larger scales, we might use something like a keyway, for example, to lock the rotation of these parts together, but there isn't enough space for that in a watch, so we make a pair of square pieces instead. To make a square hole, I must first make a brooch. The idea here is that the brooch will be pushed through the middle of the winding wheel blank to produce the square. I decided to make it quite long to allow space for multiple cutting stages, but this produced quite a fragile and flexible workpiece that I needed to support somehow. To solve this problem, I made a female half center. With the workpiece now properly supported, I went ahead with machining a relief angle between each cutting stage, and this is what the workpiece looked like. Once heat treated, it was ready to be mounted in the press for a trial. It seemed to work pretty well, but I realised too late that I forgot to design a method of extraction, and so the brooch became firmly stuck in the workpiece. Sadly, this brooch ended up becoming a sacrificial tool, but the hole at least looked pretty good. Since we're starting again, just for interest, let's try a different approach. I had this idea for a single stage punch, which would obviously be much easier to make, so let's make that next. It seemed to punch the hole quite cleanly, but the tips broke off the punch. So in the end I opted for this much shorter and therefore stronger multi-stage brooch. I made the end of the brooch smaller so I could push it all the way through to remove it from the workpiece. Under the scanning electron microscope, once it had been used a few times, you can see the early stage cutting edges suffered more wear than the later ones. Perhaps in the future I will use an even smaller step size at the start of the brooch, but since this one did the job, I'm calling the problem solved. So let's proceed with making the winding wheels. For my first attempt, I used a superglue arbor to hold the rough wheel blanks to machine them to the correct thickness, but since I have 3 to do, I decided it's worth the extra time to make up a quick collet to hold them. I faced them off slightly oversized and lapped them to their final dimension. I cut the teeth in the same way as my first attempt, before hardening the wheels and tempering them to a blue. Now, modern watchmaking is as much of an art form as it is an engineering challenge, and I know this interdisciplinary nature appeals to many watchmakers. The truth is, my background is in engineering, and I'm no artist, and so I would consider my finishing skills rather lacking. Having said that, my goal is not to make an immaculately finished watch, because it's the technical aspects that appeal to me most. But then I do like to experiment with new techniques when I can, and one of those is the art of the black polish. When something is polished to a high enough standard, from some angles you get a perfect bright reflection, and from others it looks black, hence the name. The technique you see here is one I've converged on after many hours of experimentation, and I found that tiny movements of the part on the final tin lap, loaded with 1 micron diamond, keeps the risk of contamination down. I found you have to do it in one go, because the moment you lift that part, contamination creeps in and the black polish is ruined. I'm happy with this black polish. It's hard to show on camera, but I find it kind of surreal, because almost all of the polish objects we normally interact with are actually imperfect. In this case, you get these weird reflective effects. For example, when I switch my camera to autofocus, it wants to focus on the reflection from my workshop roof blinds. Or if I put an object in front of the polished surface, the camera chooses to focus on the object's reflection, such as this screwdriver handle, because as far as the camera is concerned, the reflection looks like the real object. If we image the surface with electrons instead, you can clearly see the scratches are still there, just like any physically polished surface. They're just smaller than the wavelength of visible light. If you've been following our watchmaking series, you might remember I made the click and click spring in a previous video. In the last YouTube video, I made the main plate. And for those following on Patreon, you know that I've made the winding wheel bridge, the winding arbor, and the barrel arbors. Aside from some screws, plus an extra one to replace one I broke earlier, that's everything required to assemble the mechanism. The sawtooth or shark fin tooth profile on these winding wheels is unusual for modern watches, which typically use what's called an involute recoil pull. But still they mesh surprisingly smoothly. When I rotate the winding arbor, all 3 winding wheels rotate. The barrel arbors rotate the same direction, each winding their respective springs, which I obviously haven't fitted yet. The click or pull prevents the rotation of the winding wheels in the other direction, forcing the spring to unwind slowly through the gear train of the watch, which I will reserve for a future video. Thanks for watching. I will see you in the next one.